All right, welcome back, guys. Today, what we're going to look at is looking at box plots with a quick review in this portion of the video. And then what we're going to look at is how they can be skewed. All right, in our previous lesson, we looked at outliers, and the outliers are really where a lot of skewing comes. But sometimes, even when there isn't an outlier, you can have skewed data. We'll talk about what that means. Um, as we look at today's lesson. So, as we are looking at the box and whisker plot or box plot, let's just real quickly review how these are constructed. All right, so remember that we have our box and whisker plot. It's showing the variability of data along a number line. And we use the least value, the greatest value, or remember we call this the least value, the minimum, and the greatest value, the maximum. Okay. And what we have here is that this box plot has divided it into four portions, the quartiles. Okay. The four areas are the whisker, the left half of this box, the right half of the box, and the upper whisker. All right. So there are five numbers that do this. The minimum is the first one. The first quartile is the left half of this, the left side of this box. Then you have the median, which we referred to this before, but you could call that the second quartile, but it's usually called the median. And then we have the third quartile, and finally the maximum. Okay, so these five values make up our five number summary. And as we saw yesterday in our lesson, the interquartile range, the between the first quartile and the third quartile, this range here is what we use to help us determine if there are any outliers and whatnot. Now, just an example or just one way that we can look at this, remember that each of these parts represents 25% of the data. Okay. So even though they are spread out a little bit differently, there's still the same number of data points in each one. All right, this is something I asked you about earlier, and I had several people looking at, say, something like this and saying, oh, there's more people in this area than in this area. No, there actually aren't. They're the same number of people. It's just, or the same number of data points. It's just that the data points in this side of the box and this 25% are spread out a lot more than the ones in this one. Okay, so we have the same number of items in the two areas. It's just how far they're spread out. And that's why this says it shows the variability or how much the data is spread out in those different portions of the number line. So let's run through a quick example here. We have the numbers of first cousins of the students in a ninth grade class. It's an interesting one because depending on how many siblings each of your parents has, and then how many kids each of them have, you could have some real big differences in numbers here. So we have this data that we've collected. It looks like we got 4 by 6, so there's 24 different data points here. And we're going to create a box and whisker plot to represent this. All right, so the first thing we've got to do is when we have our data like this, we need to order it from smallest to largest. So I see a 0 there and a 1. Okay, it can be helpful to cross these out. And then I see, oh, there's 1, 2, 3, 4 threes. Okay, there's 4 threes. And we do need to list all of them. It looks like 3 is probably going to be our mode here. And then let's see, there are no 4s. There's a 5. There's a 5 there. Here's a 6. There's no 7s, but hey, there's 2 8s here, so I'm going to write down both of those. 8, 8, 9. Let's see here. Oh, there's a 10. Another 10 right there. And then no 11s, but here's a 12, a couple of 13s, and a 14. 12, 13, 13, 14. And then let's see here. Here's a 16, 18, and then 19. 18 and 19. And then we have a 23 and a 24. And then a 32 and a 45. Okay? So we have all of our data accounted for, and we've put it all in order. Now, if I'm going to try to find the 5-number summary, really what we're doing, we're cutting it into 4 groups, remember, and we're going to divide it in half by finding the median, and then divide each of those halves in half by finding the quartiles, the first and third quartile. Okay? Now, for the 5-number summary, let's first of all start with the easy ones. Okay? So we've got 0 and we've got 45. That's our max and our min. Okay, our minimum and maximum values. So minimum is 0, maximum is 45. Okay, so that's pretty easy. Now we're going to find the median, and since there are 24 total pieces of data, half of 24 is 12. So since this is an even value, our median is going to occur between the 12th and the 13th value. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so right here between the two 10s is our median. Okay, now remember, if you have it between the two values, you have to average them. But since they're the same thing, the average is going to be 10. Okay, so there we have our median of 10. Okay, so now to find the first quartile, we are going to look at the lower half of the data, and that's all of this stuff, including the minimum. It's all of these down here. Notice I am including the 10 because the median is right here. So this 10, I know they're the same number, but this 10 you can think of as being to the left of where the median is. So we are going to include that. And our first quartile there, we're going to see, okay, there's 12 values. So half of 12 is 6. So 1, 2, 3, 4, 5, 6. Okay. So our first quartile is going to occur between the 6th and the 7th term. So there's where our Q1 is going to be. And if you average those, 3 plus 5 over 2, that's 8 divided by 2, which is 4. Okay. Finally, we have our third quartile. So I'm going to go back and I'm going to look at this upper half of the data. The upper half of the data. Again, this 10 is included in the upper half because, again, even though it's the same number, it is to the right of where the median is. Okay. So again, there are 6 values. So it's the quartile, the third quartile is going to be between the 6th and 7th. So here's the 6th value, and 18 is the 7th value. So that means our Q3 is right there between 16 and 18. So if I average those together, 16 plus 18, or again, you can just think what's 16 and 18. You can also just think about, okay, what is the number exactly between 16 and 18? And that's easy to find. That's 17, okay? Or 34 divided by 2 is 17, okay? So for these, the first quartile, again, was 4, the median was 10, and the third quartile is 17, okay? So let's see here. Down below, we actually already have a box and whisker plot drawn for this data, okay? And you can see here the minimum or the least value is 0. The first quartile is that 4 right here. The median is 10. The third quartile is 17. And then here is our maximum at 45. Okay, so let's apply what we did yesterday and look at outliers. Okay, let's see. This whisker over here seems very, very long. So it's possible that 45 could be an outlier and maybe even the value before it. And I'll show you how to draw this box plot or review with you how to draw the box plot when there is an outlier. Okay, so outliers. Remember, we find the IQR, okay? So the IQR is Q3, which is 17, minus Q1. So 17 minus 4 is 13, okay? And then we need to do 1.5 times the IQR. 1.5 times the IQR is 1.5 times 13. That actually is 19.5. Half of 13 is 6.5. So you add that to the 13, you get 19.5. So remember we talked about like the fences, if you will, on our data. And those are how we can identify where our outliers might be. So the left side, on the left side, we do Q1 minus 19.5. Not equals, minus. Okay, Q1 minus 19.5. And Q1 we said was 4. So actually, if you think about this, it just logically 4 minus 19.5, that means we'd have a negative number of first cousins, which is impossible. So we don't even have to look at the data. Clearly, there are not going to be any outliers on the left side. All right, that fence would be way down here. Okay, but on the right-hand side, we're going to do Q3, and we're going to add 19.5. Okay, so Q3 is 17 plus 19.5. And that comes out to 36.5. So what that means is that our outliers, here's 35, here's 36, anything above this value is an outlier. Okay, so if I look back here at my data, I notice that 45 is the only value that is an outlier. Okay, that's an outlier. So I'm going to actually redraw the box plot real quickly here to take into account the fact that 45 is an outlier. So I come over here. I'm gonna draw it down below, and right below 45, I'm going to put an X because that 45 is an outlier. Okay, the bottom end of our box and whisker plot is all going to be the same. So here at 0, I've got my least value, my Q1 is at 4. So there's my whisker. And then my median is at 10. My third quartile is 17. All right, so you can see all this is staying the same. In fact, the box will always stay the same. So now what do I do with this top whisker? One common mistake is people say, oh, the fence was at 36.5, so I'm going to make the whisker go all the way to there. That's not what we do. Okay, I look back at my data, and the highest value that is not an outlier is this 32. Okay, so I'm going to find 32. There's 25, there's 30, 31, 32. And I'm going to draw my whisker, and I'll just label it so we remember. I'm going to draw my whisker out to 32. Okay? And I want you to understand why this is significant. Remember, we said that 25% of our data is represented here in this whisker, on the left side of the box, on the right side of the box, and on this upper whisker. And if you were to look at the original way the box plot was drawn, you would think, wow, this top 25% was really spread out. But when we take into account the outlier, we realize, okay, there was one pretty extreme value, but while this upper whisker was spread out a little bit more, it's not quite as extreme as we first thought. Okay, so this upper whisker is more spread out than the other 25% regions, but it's not quite as extreme as we first thought with the original box and whisker plot. Okay, so that is our initial look at the box and whisker plot, a quick review of what we've learned so far. So at this point, we're going to take that review and help us learn a little bit more about how to recognize skew and the different types of what we call a distribution.